Let's talk about the difference between definite and indefinite integrals. So on this side, we'll list some properties of definite integrals. On this side, we'll list some properties of indefinite integrals. Remember, by definition or by description, the definite integral from a to b of f of x dx, is equal to this limit. This limit has f of xi times delta x. Remember, this finds the area of a little skinny rectangle. We're multiplying base times height. We add up the areas of all those rectangles and we get an approximation to an area, and then we take the limit as we get more and more and more and more rectangles. And in the limit, we get this exact definite integral. That's what a definite integral is. That's where it comes from. That's what it means. An indefinite integral, by contrast, is just an antiderivative. That is, we try to think up a function capital F of x whose derivative is little f of x, and that's the indefinite integral. We may have a rule for that, like we had with the power rule. We'll see other rules later on. Or we may have to work and use all sorts of techniques to try to come up with that. Or we may not be able to find it easily at all. But that's the idea of an indefinite integral. We're trying to come up with a function whose derivative is little f. So definite integrals, they find accumulation in area. So this whole concept was to find area. When little f is negative, remember they find accumulation, area above the axis minus area below the axis. Indefinite integrals, they just find a general antiderivative function. So from this much of the table that we filled out, it doesn't even look like they're necessarily related at all. In other words, this comes about from this complicated limit. We try to find a function whose derivative is something. This is about accumulation in area. This is just a general antiderivative function. They get related through the fundamental theorem of calculus. The fundamental theorem of calculus says that the definite integral can be calculated as capital F of b minus capital F of a, where capital F prime of x is equal to f of x, little f of x, the integrand. So this capital F is an antiderivative. So indefinite integrals get used as an intermediate step in finding definite integrals using FTC, fundamental theorem of calculus. That is, the indefinite integral finds this capital F of x so that you can use it in the fundamental theorem of calculus. Well, it finds it provided you can find an antiderivative. So keep straight what these two different things are. They both use an integral sign. This one has limits. This one doesn't have limits. They start from very different definitions. They get connected by the fundamental theorem of calculus.